After more than a decade in the United States, and for the first time in Israel, we are proud to present the Blavatnik Awards for Young Scientists.
We're so honored that you are all with us tonight at this very first Blavatnik Awards in Israel.
The idea to motivate young scientists is a breakthrough in the prize awarding culture, and it is the breakthrough of our dear friend, Len Blavatnik. We are proud with a partnership with Blavatnik Family Foundation, led by Len Blavatnik, and the New York Academy of Sciences, led by President Ellis Rubinstein.
Our academy began, as you saw from that video, to identify many of America's most promising young scientists and engineers. And now they're going to be joined by the best in the UK, and the best in what I would have to say per capita is the most amazing talent pool in the world, Israel. This is why our academy is honored to play a part in the ecosystem that's developing. It's why your president, Rivlin, honored us earlier today. It's why I trust all of you will enjoy this evening and become supporters of this special event.
Like a tunnel that you follow to a tunnel of its own, down a hollow to a cavern where the sun has never shone, like a door that keeps revolving in a half-forgotten dream, or the ripples from a pebble someone tosses in a stream.
Ladies and gentlemen, the 2018 Blavatnik Awards in Israel Laureate in Chemistry, Dr. Charles Diesendruck.
So from our perspective, the stone is really only breaking at the 101st blow. But from the molecular perspective, from the chemical perspective, every time we hit the stone, we are actually breaking chemical bonds. So this is actually called mechanochemistry, and every time when we hit a material under stress, we are breaking chemical bonds. In our research, we try to take this mechanical energy, and instead of using it just to destruct the material, try to do something productive with this energy.
And in physical science and engineering, Professor Anat Levin.
So I do research in a field which is called computational photography, and I'll try to explain what it is about. So we are all used to traditional imaging, traditional photography, and in a traditional photography, what do we have? We have a 3D world, and we have a lens, and the lens collects light rays from the world and maps them into a 2D image. Now, this kind of device has lots of limitations. So what we want to do in this field is to redesign both the optics and the computational algorithms simultaneously.
And in life science, Mr. Dr. Oded Rechavi.
Honored, grateful, and almost completely speechless. What I will tell you about today is inheritance of memory, which sounds outlandish maybe at first. What I was thinking is that maybe in addition to DNA has these limitations. We are aware of them, there's no way around it. But perhaps there are other molecules that can move between generations, between somatic cells and germ cells, which are not the DNA. We know now, we sequenced, not me, the entire community sequenced hundreds of thousands of genomes already. And still, we can't understand the genetic basis of many common traits like height or intelligence, which is complex, or schizophrenia, diabetes, many traits that we can't properly track. One reason is there are many genes that contribute to them. But another reason that maybe there are additional things in addition to genes.
These young people have been chosen not only for their discoveries to date, but of course also for the promise of their future endeavors. So let's give them another round of applause. Thank you so much. We expect great things from you.
I thought of a question that I was asked a few years ago by a journalist, and that's, what is my dream? What do I dream of? And I thought I gave him a little bit of a complicated answer, and I told him that I think that something is wrong with our lives. It's too short to really witness the solution of all the problems that we as human beings are facing, defeating brain diseases, defeating cancer, defeating starvation, war,